Let's explain about what information a block contains in blockchain. In a blockchain, information is stored in blocks. A block contains a set of transactions that have been validated and confirmed by the network. The information that a block typically contains in a blockchain, along with a brief description of each. Block header. This contains metadata about the block, such as the version number, timestamp, and difficulty level of the proof-of-work algorithm used to create the block. Nonce. A random number used in the proof-of-work algorithm to generate a hash that meets certain criteria and enables the block to be added to the chain. Previous block hash. The hash of the previous block in the chain, which links the current block to the previous one and creates the chain. Merkle tree root. A hash of all the transactions included in the block, which creates a tamper-proof record of the transactions. Transactions. A list of transactions that have been validated and added to the block. Block hash. A unique code that identifies the block and ensures its integrity and immutability. Size and weight. The size and weight of the block, which is important for network bandwidth and storage capacity. Fees. The amount of fees paid by users to have their transactions included in the block. Validator or miner information. In some blockchain networks, the block may contain information about the validator or miner who created the block, such as their public key or address. Smart contract code. In some blockchain networks, the block may also contain smart contract code that executes when certain conditions are met. Additional metadata. Some blockchain networks may include additional metadata in their blocks, such as the language used to write the smart contract or the type of transaction being processed. Signature. In some blockchain networks, the block may contain a digital signature, which is a cryptographic proof that the block was created by an authorized party. Reward. In some blockchain networks that use proof-of-work or proof-of-stake algorithms, the block may contain a reward for the validator or miner who created the block. Timestamps. The block may contain multiple timestamps, including the time the block was created, the time it was added to the blockchain, and the time the transactions were initiated. Confirmation status. The number of confirmations the block has received from other nodes on the network, which indicates how many blocks have been added to the chain since the block was created. Chain history. The block may contain information about the entire history of the blockchain, including previous blocks and transactions. All of these pieces of information work together to ensure the security, transparency, and immutability of the blockchain network. By using a decentralized and transparent ledger, blockchain technology provides a way to conduct transactions that is resistant to fraud, censorship, and manipulation.